Hello, today we are going to learn how to solve index equations. We have here a series of equations which vary in increasing order of complexity. So you pay attention and see the tricks that are involved in solving such equations. We have the first one, 3 to the 2x equals 81. To solve an index equation of this form, we verify whether both sides can be expressed in index form such that the bases are the same. And if you observe well, you see that 81 can be expressed in index form with 3 as the base. So we have that 3 to the 2x equals 3 to the 4th, because 81 is 3 to the 4th. Once the bases are the same, we now equate the powers so that we have 2x, the power on the left, being equal to 4, the power on the right. And if you proceed to divide both sides by 2, you have that x equals 2. In the second example, we have 2 to the 3x minus 1 equals 0.125. So very often the examiner might decide to use a decimal number on the right hand side. In that case, you seek to change it to a fraction and then to index form. So 0.125 is the same as 125 divided by 1000, and we have that 2 to the 3x minus 1 would be equal to 1 all over 8, because 125 can go into 1000 8 times. And further, 1 all over 8 is the same as 8 to the power negative 1. That's the inverse of 8 is 1 over 8. And further, 8 is the same as 2 to the power 3. And so we have 8 to the negative 1 as 2 to the negative 3. So in this case, we have the bases the same, and so the powers should now be the same, so that we have 3x minus 1 equals negative 3. Following that, 3x equals negative 3 plus 1. You send negative 1 to the right hand side, it becomes positive. So we get 3x equals negative 2. So that upon dividing both sides by 3, x would be negative 2 all over 3. For number 3, we have 9 to the 2x plus 1 equals 1 all over 27 to the power x. Here again, we have a fraction on the right hand side. We can rewrite the equation as 9 to the 2x plus 1 equals, so 1 over 27 to the x can be written as 27 to the negative x, because that is the inverse of 27 to the x. And now, on observing, we notice that 9 and 27 have a common base, which is 3. So we're going to make use of that, because it is difficult for us to express 27 as 9 raised to a certain power directly. So in the case where the larger base cannot be expressed as the smaller one raised to a certain power, like in this case, we check that there should be a lower base that is common. And actually that lower base is 3. So 9 is the same as 3 squared. And then we have the power of 9 as 2x plus 1. And that should be equal to 27 is the same as 3 to the power 3. And we have the index or the power of 27 as negative x. From here now, the bases are the same, and we can now equate the powers, whereby we have 2 into 2x plus 1 being equal to 3 into negative x. And upon expanding the left hand side, we have 4x, that's 2 times 2x plus 2 times positive 1, which gives positive 2, equals 3 times negative x, which is negative 3x. Upon collecting like terms, we have 4x plus 3x And when negative 3x moves to the left hand side, it becomes positive, equals, we send positive 2 to the right hand side, which becomes negative 2. And so we have 4x plus 3x giving 7x equals negative 2. We divide both sides by 7, so that we have x equals negative 2 all over 7. For the last question, we have 5 to the 2x minus 1 equals 3. So number 4, 5 to the 2x minus 1 equals 3. It's difficult to have 3 raised to a certain power to give 5. So in this case, we rely on logarithms whereby we take log to base 10, preferably of both sides. Before doing that, it is good to first simplify the left hand side to avoid complications. So you would rewrite the left hand side as 5 to the 2x times 5 to the negative 1 equals 3. Remember from the laws of indices, when you multiply two indices with the same base, you add the powers. So the left hand side can still be rewritten in this form as we are seeking to simplify it. Then we note that 5 to the negative 1 is the same as 1 all over 5. So all that will be equal to 3, and we can then cross multiply to have that 5 to the 2x equals 3 times 5, which is equal to 15. We can now take log of both sides such that log of 5 to the 2x equals log of 15, so that 2x log 5 equals log 15. Remember, one of the laws of indices says you have log 5 to the 2x, the power can spring in front and multiply the log. So that's what we have applied on the left hand side. From here now we are seeking to make x the subject, so we can divide both sides by log 5, so that we get 2x equals log 15 divided by log 5, and then we multiply both sides by half, or divide both sides by 2, so that x equal half log 15 all over log 5. And this is the exact value of x. If the question asks to a certain accuracy, like the number of decimal places or the number of significant figures of the value of x, before you can turn to your calculator and write down the value. Thanks for watching, and see you in the next video.